Okay, so today we're going to talk about matrix operations. And what a matrix is a rectangular array of numbers in brackets. And it's a way to organize information. And matrices are going to end up being extremely useful to solve systems. But we've got to learn a little bit about their background before we can use that. So we're going to learn a little bit about how matrices work. And the first thing we're going to talk about is the dimensions of a matrix. Oh, you need me to go back? There is a lot of writing today, so please make sure you are keeping up as best as possible. All right. So the dimensions of a matrix is going to be given by, by m by n. Okay? The dimensions of a matrix are m by n, where m is the number of rows and n is the number of columns. Okay, make a row for me in the air in front of you. Which way does a row go? A row goes horizontally, left to right. Which way does a column go? Up and down, vertically, okay? A column, like at the White House, has columns on it, okay? So you've got to remember which way rows or columns go and which way columns go. All right, so look at matrix A. This is how we write a matrix. It is named by using a capital letter. It uses brackets, not curly, just brackets, okay, to organize our information. This matrix has 6 entries. No, you don't use commas. Okay? So the dimensions of this matrix, first we're going to count the rows. Here's 1 row, 2 rows. How many columns? 3. So the dimensions of this matrix is a 2 by 3 matrix. 2 rows by 3 columns. Okay? The address tells you the specific location of an entry. And the address is given by using the rows and columns as well. So find 8. The address of 8 is given by using a lowercase a. And that's because this was a capital A. You use a lowercase version of the capital letter. And then use subscripts for the row and then the column. So the address of 8 is A sub 2, 3. Yeah. Both the 2 and the 3 are subscripts. You would have to put a comma, I think. We won't deal with numbers that big, but you would have to use a comma, I think. No, for this case, there's no comma. Okay, what would the address be of 3? A, 1, 2. Okay? That's how I write my of. Nope, address of 8 and address of 3. Okay, copy down matrix M. What are the dimensions of matrix M? Good. What is the address of the entry at negative 3? M, 2, 1. Row, then column. rows, then columns. This is row, so this is in row 2, column 1. Okay? What is at M sub 3, 2? 2. Good. Third row, second column. Okay? All right, let's talk about adding matrices and subtracting matrices. So matrix sum and differences. To find the matrix sum and difference, the first thing you have to check is if the matrices have the exact same dimensions. Okay? So in order to add and subtract matrices, they must have the exact same dimensions. You can only add or subtract matrices with the exact same dimensions. I'll show you. Okay? The reason that is because we are going to add or subtract. We're going to combine the numbers of the same address. Okay? We're going to combine entries with the same address. And so that will only work if we have the exact same dimensions. Take a sec and copy down A, B, C, and D. Remember that you always name a matrix with a capital letter. All right, what are the dimensions of matrix A? What are the dimensions of matrix C? 2 by 2. So can I add matrix A and matrix C? Yeah, they have the exact same dimensions. So when I add matrix A and matrix C, I'm going to add the entries with the same address. So address of 1, 1, and 1, 1. So I'm going to do 7 plus 1. 8 plus 4, -2 plus 8, and -4 plus -3. And you don't have to write this step out. I'm just doing it so that when you go back and look at your notes, you'll know what we did. All right, what is 7 plus 1? Okay, 8 plus 4, 12, -2 plus 8, -4 plus -3. That is the answer to A plus C. Okay? All right. Let's do D minus B. First of all, we got to check the dimensions. What are the dimensions of D? 2 by 3. What are the dimensions of B? 2 by 3. So can we subtract them? Okay. Remember, D minus B is different than B minus A, right? 5 minus 2 is different than 2 minus 5. So you have to go in the order that it's given to you. So I've got to do D first, then subtracting B. So 0 minus -3, 4 minus 4, -4 minus 5. Keep going for the bottom row. All right, what are we going to get for our top row? -9, good. What about our bottom row? 1. Questions about that? Okay? Can I do, well, first, okay, it says A plus D, so I have to check my dimensions. Can I add A and D? No, why not? Different dimensions. So you can write not possible or not defined. And the reason is because they have different dimensions. No, because that technically means no solution when you're like solving for x. Okay, is matrix addition commutative? What does commutative mean? Do you remember? It means that like A plus B is equal to B plus A. For addition. Yes, for addition, it is. Matrix addition is commutative. Do you think subtraction is commutative? No. Commutative means that A plus B is equal to B plus A. So addition is, but subtraction is not. Okay? All right, let's talk about scalar multiplication. You might recognize that word scalar if you are in physics or you've looked at vectors before or anything like that. Scalar is just a number being multiplied by a matrix. And it's going to work just like you might expect it to. Okay, we have 1/2 times this matrix. All I will do is multiply 1/2 times each entry. Okay? And again, you don't have to write out each of these steps. I'm just doing it so that it's going to be as clear as possible when you go back and look. All right, what's 1/2 times 7? 1/2 times 8? 1/2 times -2? And 1/2 times -4. Good. All right, take a sec and copy down the matrices for number 4, please. All right. So we've got 2A times C. So what do you think that means we're going to do? Sorry, minus C. What are we going to do? Multiply A by 2 and then subtract C. Okay? So we're going to have 2 times matrix A and then we're going to subtract C. What do I need to check to make sure I can keep going? The dimensions of what? Which 2 matrices? A and C. What are the dimensions of A? 3 by 2. What are the dimensions of C? 3 by 2. Can we subtract these? Yeah. All right. Go ahead and multiply through by your 2 first. let's go ahead and subtract. 4 minus 1, 3. Negative 4 minus negative 2. Negative 2. Why? Good. When you subtract a negative, it becomes positive. So negative 4 plus 2 is negative 2. 6 minus negative 2. 8. 0 minus 5. 4 minus 0. And 1 minus 4. Did I write this down wrong? Yep, sorry, you're right. That should be a 2. Thank you. So negative 2. Okay? This is your answer. That matrix is your answer. Okay? All right. C plus 2D. Okay, we know the dimensions of C are 3 by 2. What are the dimensions of D? 2 by 3. So can I do this? No. Nope, the dimensions have to be exactly the same. Okay. B minus 3D. We know the dimensions of D are 2 by 3. What are the dimensions of B? 2 by 3. So can we do this? Yes. All right. So I've got B minus 3 times D. Okay. You have 2 options here. Those 2 options are to decide if you want to distribute or multiply through a positive 3 and then subtract, or a negative 3 and then add. Okay? That is your personal preference. You get to choose what you would like to do. Okay? If you'd rather multiply by the negative 3 and then add, or multiply by 3 and then subtract. Okay? Which one would you guys like to do? Multiply by positive 3 or negative 3? Positive. Okay. If you would rather do negative, go for it. Okay, so if we are going to multiply through by positive 3, what does the sign in between these stay? Minus. Then you would, yeah, if you multiplied by negative 3, this sign would change to plus. 0, negative 6, 9, 3, negative 15, 6. Okay? Go ahead and subtract those. All right. Let's see. Tell me what you got. Let's do the top row first. 4. Minus negative 6. So it should be 13 halves. Then what? Negative 6. Very good. You got to be really careful with your signs, right? It's easy to miss a negative here or there, so just be real careful with that. This stuff is on your quiz. Yes, I'll tell you when the information stops for tomorrow. Okay, any questions on this stuff? Okay, cool. You don't have to necessarily write this one down, but let's pay attention and look at it, okay? We want to solve for x and y. So we've got a matrix, 2 by 2 plus a 2 by 2 matrix giving us an answer. How do you think, what little mini equation might I set up to solve for x here? 3 plus x equals -2. Because I get this and each by adding the same addresses, right? Does that make sense? So what would x equal? -5. Okay, what about y? What's y going to equal? 2 plus 4 equals y, so y is 6. Okay? We okay on that? All right, cool. Now let's get to the fun stuff. Matrix multiplication. Okay? I love matrices, and I love multiplying matrices. It's really fun. No, I really do. I really like it. And we haven't gotten to teach it in the last couple of years, so I'm really glad we're teaching it again. Alrighty. Matrix multiplication can only be performed when the insides match. And I'm going to tell you what that means in just a second. Okay? Certain dimensions do. Okay. So consider that I've given you two matrices. Matrix A with dimensions of m by n, and matrix B with dimensions of n by p. Okay? What I mean by the insides is I mean these two dimensions. The columns of the first have to match the rows of the second. Okay? So this is what I mean by the insides. Okay? So what we know is that A times B is defined because my insides match. Okay? The outsides also play a part. These are your outsides, m by p. What that tells me is the dimension of my answer matrix. Okay? So the outsides, which in this case is m by p, are the dimensions of my answer matrix. Okay? So when you try and start multiplying matrices, you got to put them right next to each other and you got to write out their dimensions in the order that you plan on multiplying them. It's just basically just showing you that it's a different number than m or n. You'll see, and it'll make more sense in just a second. Okay? So look at these two matrices, A and B. Jot those down real quick. All right. We want to decide if we can find the product, and if so, what the dimensions of the matrix, answer matrix are going to be. All right, so first let's think about A times B. What are the dimensions of A? 2 by 2. What are the dimensions of B? 2 by 3. Okay, so first you compare the insides. 2 by 2. Do those match? Yeah. So if they match, that means that yes, we can multiply them. The answer is defined. Okay? Now I want to find the dimension of my answer. So to find that, I look at the outsides. The outsides are 2 by 3. So the dimension of my answer matrix is going to be a 2 by 3 matrix. Does that make more sense now? Questions? Okay, let's look at B times A. Now again, I've got to rewrite the dimensions under here. What are the dimensions of B? Yeah, 2 by 3. And what are the dimensions of A? 2 by 2. So check the insides. Can I multiply B times A? No. Why not? Good, they don't match. The insides don't match. Okay, what that tells us, if I can multiply A times matrix B, but I am not allowed to multiply matrix B times matrix A, is that matrix multiplication is not commutative. It does not work just like in real numbers, where in our system 2 times 3 is the same as 3 times 2. Because of what I'm going to show you of how we multiply matrices, they are not the same. Okay? So matrix multiplication is not commutative. All right, you can draw yourself a line or put a star. This is the end of the material for the quiz tomorrow. Actually multiplying matrices will not be on the quiz, just telling me if you can multiply them. Okay? Yes, it will be on the test. I just want to give you more time to practice next week. Okay. Let's actually multiply. To multiply, you're going to keep repeating to yourself. Row by column. Row by column. I'm going to tell you what that means. Okay? Row by column. So, copy down matrix A and matrix B. What are the dimensions of matrix A? 2 by 2. What are the dimensions of matrix B? Am I allowed to multiply A times B? Yes. Yeah. 2 matches 2. What will the dimensions of my solution matrix be? 2 by 2. All right. This is going to seem weird at first, but I want you just to stay with me. Okay? So, my solution matrix is going to be a 2 by 2. So that means I'm going to have 4 entries in it. 1, 2, 3, 4. I'm drawing these long for a reason. You'll see. Okay. To fill this first spot, this is in the first row and the first column. So I'm going to take the first row from A and the first column from B. So I'm going to do 4 times -1 plus, still working on the top row in the first column, 7 times 6. Okay? You go first row and first column. 4 times -1 plus 7 times 6. Okay, now let's fill this spot. That's the first row, but the second column. So first row, second column. So I'm going to do 4 times 5 plus 7 times -3. Okay, let's look at this spot. Second row, first column, right? So we're going to take the second row from A, the first column from B. So 8 times -1 plus 2 times 6. Okay. Last spot, bottom row, second row, second column. Second row, second column. 8 times 5 plus 2 times negative 3. Okay? Then we just simplify each term. So, negative 4 plus 42, what does that give us? 30 what? 38. 20 plus negative 21. And 1. Negative 8 plus 12. 4. And 40 plus negative 6. 34. That is our solution when we multiply matrix A by matrix B. Little weird as long as you learn the process. Yeah?
If it was going to be like where matrix A had a dimension of 2 by 2, but B was like 2 by 3 or 3 by 3, like would the answer be different?
What do you mean different?
Like if you had like, would it be like 1, 2, but B was 2?
No, you will always use every term. That's why the insides have to match. This process works. Okay, now let's do B times A. I strongly encourage, if not require you here, to rewrite this in the order B times A. I don't think this is something you should try and eyeball going backwards or something. I think that can get really confusing. So I would go ahead and rewrite this in the correct order that we're going to multiply. B times A. Are we still allowed to multiply these? Yeah, because this is a 2 by 2 times a 2 by 2. So our insides match. What are the dimensions of our solution? 2 by 2. All right, same process. Top row, first column. So I'm going to do negative 1 times what? 4 plus 5 times 8. Row by column. All right, top row, second column. Negative 1 times 7 plus 5 times 2. Second row, first column. 6 times 4 plus, be careful with that negative, I would put it in parentheses, negative 3 times 8. And we're going to have 6 times 7 plus negative 3 times 2. All right. Negative 4 plus 40? 36. Negative 7 plus 10? 24 plus negative 24? And 42 plus negative 6. All right, so we've done B times A and A times B. Do you believe me that matrix multiplication is not commutative? We get 2 different answers, right? Okay, let's look at one where the dimensions don't match quite as well. And all I mean by that is that it's not a 2 by 2 times a 2 by 2. We've got a little bit different dimensions. Okay, what are the dimensions of A? Almost? 3 by 2. What are the dimensions of B? 3 by 3. Okay, so matrix A is a 3 by 2. Matrix B is a 3 by 3. Can I multiply these? No. Nope. The insides don't match. So this is not defined or not possible. let's see if we can multiply matrix B times matrix A. 3 by 3 times 3 by 2. Can I do that? Yes. What's my solution matrix going to be? 3 by 2. All right. So what do you think the first thing we should do is? Yeah, let's rewrite them in the order of B times A. All right. So I'm going to have a 3 by 2. I sometimes like to draw it out so that I know what spots I'm trying to fill. You don't have to do that. It's just something I do. Okay? All right. Top row, first column. So I'm going to go 5 times 1 plus 4 times 8 plus 3 times 7. Everyone okay with that? First row by the first column. See that? Okay. Top row, second column. So 5 times what? 4 plus 4 times what? Great. Plus 3 times 8. Top row, second column. All right. Second row, first column. So I get the second row here times the first column. So 0 times 1 plus 1 times 8 plus 2 times 7. Middle row, second column. 0 times 4 plus 1 times negative 3 plus 2 times 8. Okay? Bell's about to ring on us, but you would keep going. Do you understand the process? Okay? Guys, you can omit numbers 18 through 21 from your homework tonight. Okay? It was a really long homework assignment. So you can omit 18 through 21 from your homework. Okay? All right. Have a great day. I'll see some of y'all after school.